For us to live and build communities in space, we will need law and order. But who will make the rules, what should they be, and what sheriff will see that the law is enforced? To discuss the future of space law and regulation, we need to begin with existing space law, and that mostly hinges on whatever country you live in, and the Outer Space Treaty of 1967, and the Liability Convention of 1972, and arguably the Moon Agreement of 1984. I should state from the outset that I don't personally give the OST any ethical validity. You can view it as a reasonable first attempt by nations to amicably manage emerging efforts in space, or less kindly, but either way it's a placeholder until something else emerges, and hopefully better. Some oversights have been addressed. For instance, the OST doesn't handle space debris, but the Liability Convention from 5 years later does. We could chop at it all day long, but I do view it as a mostly well-intentioned document. Nonetheless, there's some key flaws or concerns raised about it. First and foremost, it's often just vague and ambiguous. The OST sets broad principles but lacks specific details on many issues. For instance, it states that space and celestial bodies are the province of all mankind, but does not define what that means in practical terms, particularly regarding resource utilization. In some ways, that vagueness is good. It recognizes that they didn't know how to handle a lot of problems, or even what those problems will be, and punts to a future generation or a judge who can create some case law, which can then be ignored or overruled by new legal statutes if it's really bad precedent. The OST is also from a period where only the government launched stuff. With the rise of private space companies, the treaties provisions that hold countries responsible for both governmental and non-governmental activities in space may be challenging to enforce. Those companies can't really rise much if they can't own things or exploit resources in space, and the big glaring flaw of the OST is that it prohibits national appropriation of celestial bodies, but does not clarify the rights and framework for exploiting resources, like asteroid mining. You can argue that even taking a sample from the moon or an asteroid is illegal, but this at least seems academic, as nobody seems to support that being the case. That the OST or future treaties should ban even taking samples, merely that it could be argued to be the case, though it does have some relevance to contamination concerns which we'll get to later. This ambiguity has led to varying interpretations by different countries too, but that ambiguity does not alter that it bans space colonization and arguably even interstellar space colonization. There's also no real enforcement mechanism or clear method for reasonable updates and evolutions, and I tend to be in the camp that reasons that if a law exists that no one really thinks makes sense, outright bans things we all want to do, like space settlement, and is not enforced or set up to be improved, then it isn't worth discussing in great depth. For all those reasons, I don't really spend much time referencing the OST in other videos, and we won't be referencing much for the rest of today too, but since existing rules are likely to influence near-term future ones, I think we must be aware of it. Current issues. In addition to existing treaties and laws, in order to discuss future space colonization and regulation, we also need to consider the current issues in play or on the near horizon. In no particular order, those are commercial, space debris, asteroid defense, asteroid mining, militarization and weaponization of space, contamination of worlds, ours or the new ones, bioexplorations, and territorial rights. We will cover those in order, but territory breaks both into who owns distant worlds beyond our moon and who owns orbital space. However, it goes beyond the strictly physical, because who owns space isn't like saying who owns the moon or who owns Antarctica. There's a volume around Earth that things can orbit in and crisscross based on angle of orbit, altitude or semi-major axis of orbit, and eccentricity of orbit. So who owns a given orbit? Does the passage of an orbit over a given nation give partial ownership or a stake over that orbit? We would usually say so about the airspace above a land, so does the altitude of that orbit matter? Or percentage of time, so that things in geostationary orbit over a place are in its territory? What about a power satellite or solar shade or mirror? These are enormous constructs potentially thinner than tin foil, so that even a few tons of material might cover entire square miles or kilometers. Who owns those photons it's collecting or reflecting? In the past, people or countries owned land and that was their main wealth, but we need to widen that in modern times and further in the future in orbital space. There's a long-running military science fiction series by David Weber, often nicknamed the Honorverse for its main protagonist, Honor Harrington, that features her native Star Kingdom's approach to land grants like we give the aristocrats of old. We are told it can include things like owning a certain band of wavelength around a planet, so that you will be able to rent out the radio channels in it. Who owns a wavelength? Nowadays we say the country where it's at, but this might need to shift up into space as we contemplate options like space-based microwave power transmission. And again, our goal here is not to say what is in great detail, as our rules currently are essentially our patchwork quilt of handling these as unrelated problems as they arose, nor can I really say what these rules should be in the future, but instead we merely note these problems for consideration. They extend to many other things as well, as we have the geostationary orbit, plus the lunar and solar Lagrange points with Earth to represent some analogy to a fixed volume of space in a more classical sense. Who has priority, and in what regard? For instance, those solar shades and mirrors might be critical to weather and climate control on Earth and future terraforming on other planets, but they represent a particularly troublesome matter for regulation, as they are essentially solar sails and examples of what I dubbed a lagite some years back. This is an object in between normal orbiting bodies and the static satellites or statites proposed by Robert Forward. These statites can have a precise surface density to let them hover over a star rather than orbiting it, with gravity pulling them and light pushing them away with equal force, and both falling off in strength inverse square to distance. The lagite dwells between them, able to combine normal orbital mechanics with solar radiant pressure to achieve normally impossible orbits. It might also do this in conjunction with solar wind or even some beam it was emitting that had momentum, like an energy beam to a planet, or potentially even cargo pods of matter it was receiving or firing off. I suspect we'll see a lot of these in the future, inevitably for thin sail-like structures, but they offer us a conflicting case as one might orbit at the same period but a higher or lower altitude than a typical satellite. Hence you might have a transmitting satellite trying to send or receive to Earth with one of these lagites stuck right between them all of the time. Needless to say, even if no one is trying to be obstructive in its use, these sorts of ultra-thin and large orbitals are going to represent protracted blockages in signal and visibility, and are also very vulnerable to space debris. This is a good segue into commercialization though, because a future in space does not exist unless it can support itself, and indeed will always be slow to grow unless it's profitable. Profitability can be a bit vague of course, and even in a hypothetical moneyless society, the projects need to be viewed as worthy to be continued. We did not make any money off the moon landings, we in this case being US taxpayers, but not many regret that, and so you can make the case that space does not, at least for now, need to be directly profitable, as people are willing to buy tickets to the show, so to speak. And the efforts can have secondary benefits like technologies with terrestrial usage. However, most of us feel commercial ventures in space will rapidly accelerate that growth in space and improve our efforts there in many ways. The question then becomes, how do we regulate so as to encourage those commercial ventures while not endangering other operations, creating long-term costly problems like space debris, or ceding rights over something the public has claimed to? As an example of that last, we could imagine creating a planetary Wi-Fi internet on that 2.4 GHz band we use now. We could imagine a company having that contract for maintaining the satellites, software, and customer service, but we wouldn't like to just give them that 2.4 GHz band or sell it. We might lease it to them for 25 years. Incidentally, that is not a prediction or recommendation, merely an example. Nonetheless, I could imagine that something like this was done by settlers on a new planet. We talk about getting investors for interstellar journeys that might take a century to get to a new planet, and centuries more to become a real civilization, and that's a hard sell even inside a long-lived civilization with radical life extension. but I could absolutely imagine getting investors by auctioning off the rights to a few bands of frequency, say 2.4, 4.8, and 9.6 GHz and so on, so long as they only monopolize that frequency and you build in a few obvious safeguards for monitoring and special access. The commercial value of that is huge, but no threat to the colony. As an example of regulation, you might have price caps or eminent domain options for it, but it also might be something built right into your colonial charter that you worry might have major long-term negative consequences if you back out of it. Time lag in space travel and communication at the interstellar scale tend to encourage stability and trust in your promises, and these will then be major coins a given star system would guard like a hawk. That's a little further future, and indeed so is a lot of space commercialization I think would be fun for today, and we'll carry it over into next week's episode on Lagrange Point Space Settlement. In the near term, a lot of space commercialization regulations are going to be about who owns something, and that's not necessarily who launched it. Much of that is just establishing precedents and mining current case law in space or on Earth for suggestions on how to adapt it. A quick clarification: statute law is what legislative bodies like Congress or your parliament actually create, verbatim, whereas case law, which is the bigger chunk of it, is all those gray area cases that some judges had to rule on, particularly when two laws overlapped on something and a real-world case has two parties each making entirely reasonable, or at least logically coherent, claims based on the law but opposed. The one that most recently comes to mind from personal use, over in my other job doing election adjudication, was that a law vaguely stated that something would happen, but didn't say whose job it was to actually do it. And sometimes it might state it, but the position responsible was divided into 2 or 3 other jobs as time went on, and that minor duty got missed when assigning them. And that happens all the time in law, and sometimes because no one thought to add it or because the answer seemed obvious, and sometimes probably with the intent of just punting that problem to the next generation. Examples we might expect would be companies or countries who signed onto an agreement suddenly ceasing to exist or merging with other entities. The dissolving of the Soviet Union at the end of the Cold War would be an example, and one that was quite pertinent to space law. This can also include groups being placed in limbo. Commercially speaking, uncertainties in the law are usually a bad thing, as while some can exploit them and profit, it generally scares off development when a body isn't sure they are on solid legal ground where their ownership or investment is or will be down the road. For instance, at the moment there's a big gray area on if you can actually own any object in space, and if you could mine an asteroid and sell the metal or fuel you made from it. You could probably get away with ignoring that. No one with any real capability to object has much motive to currently, but anyone wanting to invest in an asteroid development company needs to factor in the additional risk that if they are successful, they might get their assets seized or some unknown new tax will be applied. You can probably get an insurance policy to cover that, but then that's an extra cost too. A lot of times though, we come up with a law or decision and everyone quietly ignores it a generation later because it's kind of embarrassing in retrospect. I suspect anything we do involving property rights in space now, including doing nothing, will get viewed as mistakes down the road. That doesn't mean we should do nothing, of course, and many are hard to predict. As an example, we have a lot of laws still that specifically and casually say man, where depending on the usage, maybe they should say man, or maybe they should really say human, or just adult or sound mind. And in the future, we might need to consider what those would need to say if we are talking about a fully sentient AI, or super intelligent dolphin or chimp, or a collective human hive mind. As a general FYI, I usually just use the term person for any of those cases, and crewed for any spacecraft one of those entities might be running, and use manned for typical humans. Context will probably make it clearer in other episodes, but for today's context we are going to assume property rights, and that the term persons is only assuming a normal model human or an incorporated entity like a government, foundation, or corporation, as is already well understood in modern law. When do you stop owning something, beyond selling or giving it? If your satellite breaks up, do you still own the fragments? If so, can someone still claim them under salvage? And if not, can they still whack you with a lawsuit when a fragment hits their property? What if two satellites impacted and we now have no possible way to determine which bit came from which board? Can X sue Y for blocking the sunlight that their satellite should get? Can the owner of that satellite be sued for blocking sunlight that should hit a country, or reflecting sunlight down on them in excess of the normal amount? Sounds absurd, but when we move from talking about a few square meters of panel to several thousand kilometers of panels, the game changes a ton. It also matters when we contemplate space debris. Now, thankfully, something like a thin mesh shade or mirror takes very little damage when struck by a hypervelocity piece of shrapnel, the same as a machine gun isn't terribly effective against a billboard or ship sail. It gets a hole poked in it, and if you have enough tiny debris, it can effectively get eroded and need repaired or recycled. Very thick armor on bigger ships and stations can help against the problem too, but obviously you have a lot of applications where being thin and low value, or armored like a main battle tank, is not efficient. Currently, under the 1972 Liability Convention, the launching state is liable for damage caused by their space objects on the Earth's surface or in space. This treaty encourages states to prevent the creation of debris since they could be held accountable for resulting damages. They presumably then have jurisdiction over how they regulate launches and debris control on those things being launched, which is handy as jurisdiction over a given region of space doesn't seem too likely. Though in the long term, one could imagine that an independent moon colony or Lagrange point settlement might declare they have physical jurisdiction. What's more, there is obviously an issue if someone blows up your satellite and causes it to damage others, and who arbitrates on country X saying country Y zapped their board, and Y saying they did not, or they did but only because it was off trajectory and dangerously likely to intersect one of their space stations, or was leaking debris from the damage that knocked it off course and they zapped it for safety's sake while the owners still thought it was salvageable. Now, last month we discussed how to clear space debris, and there are a lot of possible methods, but the big one is just to minimize how much you generate in the first place, and this is an area where regulation is probably critical, and where doing it badly could either strangle space development if too heavy-handed, or badly targeted, or leave us vulnerable to Kessler syndrome, where cascading damage floods low orbital space with trillions of dollars of once valuable satellites and facilities now turned into hyperdestructive shrapnel. Asteroids and space mining. It is worth remembering that space debris represents not just a potential hazard, but also a potential gold mine. Recycling old satellites while getting paid to pick them up could represent a significant sector of the space economy, but moreover, not all space debris is all junk. Indeed, outside of our orbital space, virtually all the debris we need to worry about is micrometeors and asteroids. We have multiple episodes dedicated to both asteroid mining and asteroid defense that get into the how-to of doing either, but here our main concern is how we would regulate that. Ignoring that the OST doesn't really allow asteroid mining, which I assume everyone will simply ignore in the future anyway, the regulatory issues are mostly threefold. First, how do we decide who owns what? And that might be a process for letting nations claim bits and pieces, then sell them off as they please, or it might be some global action where the purchaser is buying them from the UN, and then they divide up the cash and assign jurisdiction using some internal formula, probably one that after careful negotiation everybody agrees to and absolutely hates. Second is the debris and alteration issue, as mining an object with no significant gravity is by default going to blow huge amounts of debris into space around it. It is a real concern, but thankfully, especially for the next few centuries, a lesser one. There are a number of ways to mitigate debris coming out, and it's not initially much of a concern when we're contemplating the asteroid belt, which is huge and empty even compared to cislunar orbital space, let alone low orbit where debris is the main concern. Third is transport home. Several tons of metal winging its way back to Earth space from hundreds of millions of miles away leaves a lot of room for error and a lot of reason for regulations on how to do it, and it likely won't just be tons but kilotons or even megatons of metals coming back in, or even smaller asteroids being maneuvered into orbit to allow them to be turned into space habitats. Do you need to announce what your cargo is and what its trajectory will be? Do you need to put beacons on it? What do we do about the company that was worried about piracy and so was labeling their shipments as iron even when they were platinum, and so when one went off course and had to be shot down, before it hit a French space station, all the numbers were wrong for the intercept, and scatter calculations, and a 100-ton slab of platinum crashed into the suburbs of London after crashing through that space station. And now England is claiming the $4 billion meteorite, which is also now the only remaining asset of that mining company as it gets seized and sued into oblivion. That, incidentally, is implying someone had a way to blow that rogue spacecraft up, or some dangerous asteroid that might get near us undetected, which leads us to weaponization of space. Mining large near asteroids strikes me as a much better way to handle dangerous asteroids than simply blowing them up, but we need that capability too, and it raises the sticky issue of weaponizing spacecraft and putting weapons in orbit. Now, as channel regulars know, there is no such thing as an unarmed spacecraft, so long as it's got some guidance and fuel available. This is for the same reason a car can be used very destructively even without mounting weapons on it. But there's a big difference between a regular car and a military Jeep or Humvee with some armor and a heavy machine gun on it. Needless to say, there's an even bigger difference between these and a main battle tank or self-propelled howitzer. There are no nuclear weapons or WMDs allowed in space, but small arms are allowed, and at the moment, not with the intent of repelling aliens or boarding parties. Some Russian missions had pistols on board, which really had nothing to do with space, but rather to safeguard the astronaut if they came down in unsafe territory. The usual example is Alexei Leonev, who did the first spacewalk back in 1965, and who landed in Arctic tundra after a spacewalk with his crewmate Pavel or Pasha Belyayev, and it was a couple of days before they could get picked up, so they were very glad for a weapon against wolves and bears rather than aliens. There are no wolves or bears in space, and thus far no aliens, but part of traffic and debris management in space is deciding who has authority to fire and what they can have up there. What do you do if a piece of debris or small asteroid is approaching your station? What about a ship? Possibly a damaged one heading your way, and very fast too. Time is minimal when speeds involved aren't tens of meters per second, like with vehicles on the road, but tens of kilometers per second. We may have no choice but to allow not just powerful weapons in space, but automated fire control, with robots deciding when to engage and with inherently lethal force. Trying to draw the line on where we can have weapons and what types are tricky, as we are mostly worried about people using orbital weapons against Earth, but the need for protection against asteroids or for clearance is real. Asteroids are not the only threat from afar, and planetary contamination is a concern and a two-way street. Right now, we have no verifiable extraterrestrial life forms, and thus do not have a clear danger of contamination, but we don't know if there are microbes on Mars yet, and if we might wipe out some fragile ecosystem there by introducing terrestrial life, or if we might bring a probe home covered in virulent extraterrestrial viruses. As we journey out to Mars and Venus and Europa and Titan, all of whom have plausible arguments for possibly housing life, we need to update and improve policies and rules on this concern, as well as enforcement, as it is not allowed under the OST, but by and large is given lip service and often not really taken very seriously outside of science fiction. Long before we get to some distant exoplanet which might house significant amounts of life, or even intelligent life, we need to decide what the rules will be on contamination and what the enforcement mechanism would be. After all, once a ship leaves on an interstellar flight, it becomes rather difficult to enforce rules or even monitor what they're up to. Interstellar trips and inhabited exoplanets are beyond our scope for today, but that discussion needs to be had before those trips occur. I would guess that until we find some solid sign of extraterrestrial life in this solar system though, or elsewhere, we won't see any significant increase in our concerns over planetary contamination. We should discuss it before then, but until then that conversation isn't likely to result in any new form rules. The same probably applies to bioforming and terraforming, and we discussed both before in their own episodes if you want to learn more about the techniques, but in short form, bioforming is when you adapt an organism to a plant's environment, like modifying lungs to breathe a lower oxygen mix, and terraforming is where you are modifying a planet to be more Earth-like, in this case giving an atmospheric mix and density of oxygen matching Earth's own. This raises a host of concerns, especially on inspection. no one entity is going to get to own Mars, short of a massive war here or there. So what happens when the 100 different bases from 50 different countries of origin settle in and grow there and have different attitudes about terraforming? And some may utterly ban bioforming. 50 of them want to terraform, 10 don't want to mess with pristine Mars, and 40 others prefer domes as they can mass manufacture and dump waste gas all over the terrain as long as it's a barren red rock. Who decides who does what? Do the asteroid miners on some larger asteroid have to vote to decide if they're going to mine it out and transform the empty tunnels into space habitats, or disassemble it into a bigger protective sphere around future habitats, or even move that asteroid to an orbit that's more favorable, such as Earth distance or transforming it into an Aldrin cycler? And in the centuries to come, as interstellar colonies journey out, will their charters have to include their intentions for terraforming and bioforming before they go? A colonial charter also raises colonial rights, and I just mentioned terraforming and bioforming as a concern to those colonists, but there will be many more, and I suspect as we colonize the galaxy, the number of strange new laws and special cases that strange new planets add will need a planetary-sized legal library to house them all. Are the colonists who arrive in a new world after a century of travel still bound by whatever colonial charter they signed, or perhaps their ancestors signed, when they left dark above Earth? Do those colonists have a claim on an entire solar system or just one planet? Or even one planet? Can a colony of 10,000 really claim an entire planet from day zero, when it would take 1,000,000 times their number to fill it? Who owns the spaceship they came on, and who decides who owns what part of their claim? Again, is it the whole system? And if so, where does a system end? The heliopause? Those vary by the sun, and for mid-range binaries might get tricky to define. One light day from the biggest sun center, or light week, light month, a whole light year, half the distance to the nearest star in that direction? Do they have a right to defend themselves or their territory if some other colony ship from another group or nation arrives planning to settle another planet, or even just another continent? Odds are decent that long before we send out the first true interstellar colony, we'll have worked out some basics for what the rights of those colonies are, but in this solar system those will likely be small offshoots of existing nations. There probably won't be a unified Mars or Moon, but rather hundreds of smaller settlements who are all territories of some Earth-based nation and want to remain that way. They may see their path forward as becoming another American state or member of the EU, or even more modestly just a county inside an existing state, or possibly a mostly on paper member of a smaller nation here on Earth in a client relationship, like if several hundred larger space hotels and casinos would ask some island nation on Earth to be their official nation for legal matters, and to whom they pay some minimal member fee, or to some bigger nation with military might who agrees to handle defense for them for a kickback from their combine. A path for actual sovereignty as a free nation is likely to be further off, and ironically might occur at the interstellar scale sooner. There is not a lot of historical precedent for nations having an exit clause, and one that the territory in question gets sole authority to exercise. Plus, inside this solar system, everyone is within a day of communication time, not the months or weeks that tended to delay communications and often were critical factors in why regions wanted to leave the nation they were part of, and what allowed relations to degenerate to that point. However, as long as light speed limits our travel and communication, an interstellar colony must be independent from day one, and indeed, unless they are frozen for the voyage, must exercise governmental powers for many years, if not centuries, before the new land is reached. Those interstellar ships may be the basis for much of our interstellar law and regulation long before the colonies they found, and indeed the exchanges between those systems by interstellar ships bringing trade or migrants, trying to conduct business and sign contracts over the vast gulf of space and time, separating those new worlds, may be where we see some form of galactic law and regulation begin, rather than any interstellar federation of planets. As we reach out to the heavens and try to transplant our civilization there, so too will spread our need for stability and binding rules and agreements. I expect no uniformity in those, any more than on Earth. But as we've seen today, while our future in space will hopefully offer us great freedom to build new lives among the stars, it will still need some rules and regulations. One of the things I love about doing this show is that one day we can be talking about a topic like space law and regulation, and the next about giant space monsters. And this month's Nebula exclusive will be examining everything from huge space kraken to kaiju and the sandworms of Dune to ask what science tells us about their biology and if we might end up encountering, or even engineering, enormous space creatures. And of course, if and how some explorers or pioneers might survive encountering or fighting one. That's out now exclusively on Nebula, our streaming service, where you can see every regular episode of SFIA a few days early and ad-free, and all our other bonus content, including extended editions of mini-episodes and more Nebula exclusives like Giant Space Monsters, the Fermi Paradox, Hermit Shoplifter Hypothesis, Ultra-Relativistic Spaceships, Dark Stars at the Beginning of Time, Life as an Asteroid Miner, Nomadic Miners on the Moon, Space Freighters, Retrocausality, Orc OR and Free Will, Colonizing Binary Stars, and more. Nebula has tons of great content from an ever-growing community of creators. Using my link and discount is available now for just over $2.50 a month, less than the price of the drink or snack you might have been enjoying during the episode. When you sign up at my link, go.nebula.tv/IsaacArthur and use my code IsaacArthur, you not only get access to all the great stuff Nebula offers, like giant space monsters, you'll also be directly supporting this show. Again, to see SFIA early, ad-free, and with all the exclusive bonus content, go to go.nebula.tv/IsaacArthur. This week we looked at regulating space, and next week we'll be looking at real estate in space as we ask what Lagrange points are, why they are so valuable as locations, and what settling them might be like. Then we'll explore conformal cyclic cosmology and the possibility that a previous universe may have existed over which ours is layered on top, before we head into February to look at death worlds and surviving on ultra-dangerous planets. Then on February 8th we'll examine homesteading in space and what might draw pioneers to new colonies and what sorts of life and challenges they would face. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon. And if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service Nebula, along with hours of bonus content like Giant Space Monsters at go.nebula.tv/IsaacArthur. As always, thanks for watching and have a great week.